Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 1. This is Section 11.1, Problem number 1. It says consider the function f of x equals 3x squared minus 1, and then it wants you to find three different limits. The limit of the function as x approaches 0, then as x approaches 2, and part C as x approaches minus 2. So we want to see what happens as you use an input value very close to 0 in our function of 3x squared minus 1. Well, since this input value is not zeroing a denominator or doing anything bad, we can just really see what happens as we let the input get very close to 0. So 3x squared gets very close to 3 times 0 squared minus 1. Well, as you run the input very close to 0, the 0 squared times 3 will disappear, and the output, or height on the graph that you will approach, is a height of -1. So that's the answer to part A. Now B, the same function, f of x is 3x squared minus 1. Now see what happens as you let the input values, or x values on the graph, get really close to 2. So again, we're not really putting in a 2, we're putting in like 1.9999 or 2.000001. But what height or output it'll get close to is very close to what's happening when you put in a 2. So the output is going to get very close to 3 times 2 squared minus 1. So the 2 squared will become a 4, times the 3 in front, 4 times 3. The output gets close to 12 minus 1, or positive 11. So as the input gets close to 2, or your distance on the x-axis gets close to 2, the output, or height on your graph of this, would get close to 11. That's part B. And then part C, find the limit of the same function, 3x squared minus 1, as the input gets very close to -2. So as you put in an input value of close to back 2 on your x-axis, what height are you getting close to on the y-axis? What output are you getting close to? So again, in reality, when we take the limit, we're putting in values like -1.999, -2.0001. But to see what height you get close to, in this case, we can actually just put the 2 in, the -2, and see what happens. So the 3x squared becomes 3 times -2 squared, or second power, minus 1. And as you do the math, it's actually the same answer as the previous problem. Because of the -2 to an even power, it's positive 4 times the 3 in front is 12 again. And don't forget there's a minus 1 just because it's part of the function. 12 minus 1, the output, or value of the limit, is positive 11.